Alright, so let's get started. Our first question here, we want to know what is the mean of the data in this dot plot. So when it's asking for the mean, it's asking for the average. So each dot above your number represents how many of that number you have. So with 3, I have 3 dots above 3, which means if I were to write a list, I would have 3, 3, 3. I would have 3 threes. With 4, there are 5 dots above 4, so if I were to write that out in list form, I would have 4, 4, 4, 4, 4, 5 times. So we don't need to write that out. We can actually just start typing this into a calculator. So remember, mean means average. So we need to add up all of these numbers together, and we need to divide it by the total number of numbers that we added together. So I'm just going to double check that I'm adding the right amount of numbers for each one. 2, 3, 4, 5, 2 7s, 1 8, and 1 9. So when I add all of those together, I get 90. And let's count how many dots we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 19 divided by 20 gives me 4.5. So our answer for number 1 here would be 4.5. Alright, next one. So here we have these two dot plots for Office A and Office B, and they represent how much they're paying on lunch. Okay, based on examining the dot plots visually, which office seems to have a greater average lunch cost? So we're looking to see which one, based off of these dots, looks like it has a higher lunch price. And if I look here, there's a lot of dots in this area, specifically 12. There's 4 above 12. And on Office B, a lot of them are focused on this $3 and $4 lunches, but it looks like Office A has a bunch that are 12. So Office A would have a higher lunch price because more of the points are clustered on the right. So that'd be over here, right of our box plot. So Office A, because more of the points are clustered on the right than the ones in Office B. All right, number 3. So we have this table here, and it gives us the mean and mean absolute deviations, or MAD, for the samples in 4 different neighborhoods. Based on the information in the table, which neighborhood is likely to have the most variation? So anytime you see the word variation, that goes hand in hand with your mean absolute deviation. So I want to know which one has the most variation, so I'm looking for the highest mean absolute deviation. So highest mean absolute deviation from this table is going to be neighborhood D. 12 is the biggest, so neighborhood D is likely to have the most variation in age. So neighborhood D. Alright, this question says that dataset A has more variability than dataset B. Which of the following can be true? Okay, well, remember that variability goes hand in hand with mean absolute deviation, so I am going to answer one of these, meaning I want mean absolute deviation in my explanation because that's what variability is referencing. And since dataset A has more, that means that dataset A must be bigger. So dataset A is greater than the mean absolute deviation for dataset B. Alright, the following dot plots shows the number of guests seated at the table at a restaurant on Friday and Saturday. Based on examining the plots visually, which day of the week seems to have the larger mean party size and why? Alright, so mean is our average. Okay, so we are looking to see which one we think is going to have a higher mean. And think about when you are adding numbers together, if you have a lot more bigger numbers that you're adding together, your mean is going to be higher because you're adding together many more larger numbers. Now here are number span is about the same. However, on Saturday, there is a lot more people on the right side of this dot plot, giving us many more numbers. So I would say that Saturday is probably going to have a higher average party size or higher mean party size because a lot of this data is shoved over here to this right side between 11 and 15. So Saturday, because more of the points are clustered on the right than they are on Friday. All right, 6. So the dot plots shows the heights of players on two different volleyball teams. Based on examining the plots visually, which statement best compares the variability of these two teams? Okay, so we're asked about variability, and that is asking us which one. It's asking us about the spread of numbers. So if your smallest number and your biggest number are further apart, you have greater variability. If your smallest number and biggest number are closer together, that set would have less variability. So looking at these two data sets, Team A's first number is on 66 and the last one is on 74, versus Team B, first number is on 67, last number is on 70, which means that Team A is going to have more variation in height because our starting and our ending numbers are further apart. All right. Following table shows the mean and mean absolute deviations for 4 data sets. Based on the information in the table, which data set is likely to be most varied? So again, I'm asking which one is most varied, which one has the biggest mean absolute deviation? Dataset C. So dataset C because it has the greatest MAD. All right, we want to know what is the mean absolute deviation of the dataset in the dot plot. Okay, so I believe this is the same dot plot we did for number 1, which is where we found our mean. Perfect. So that is actually really nice because in order to find our mean absolute deviation, remember we need to know what our average is. And our average is 4.5. So what we need to do with that average is figure out how far apart each one of these points is from our average. And to do that, we would do subtraction. And we need to subtract every single point from our mean. So 4.5 minus 1, 4.5 minus 2. Don't forget that I need to subtract 4.5 from 2 twice because there are 2 dots above 2. So 4.5 minus 3, 4.5 minus 3. Whoops. I wonder if I could just copy paste this. I can't. And then for 4, I'm going to backspace this and put a 4, and I'm going to copy paste this 5 times. So 1, 2, 3, 4, 5 because I have 5 dots. And now I have to do 5. Whoops. So because now my points are bigger, I'm going to subtract the point value first because I want to make sure I'm getting positive numbers. Oh, whoops, I think I changed it. There we go. There we go. And I am going to paste this 5 times as well because I have 5 dots above 5. So 1, 2, 3, 4, 5. Then I have 7 minus 4.5 twice, 8 minus 4.5, and 9 minus 4.5. Okay, so that's our first step. Now what we need to do is take all of these numbers that we got, our distances when we subtracted, all of these over here in this column over here, add them all together, and then divide it by the total number of numbers. So this is where I would maybe write these down so that you don't miss any. But you can keep scrolling back and forth from this bottom to the top to make sure you're not skipping any. So 3.5 plus 2.5 twice. After that, we had 3 1.5s. Then we had, let's see, how many 0.5s? We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I'm going to do here is I'm going to type in 10 times 0.5 because I have 10 of those. And that way I don't have to write out 0.5 10 times. You are more than welcome to do that if you would like. And then I have 2.5 plus 2.5 plus 3.5 plus 4.5. Perfect. So I get 31. And if I remember correctly, we had 20 numbers. So this is 10, 15, 16, 17, 18, 19, 20. So let's divide that by 20, and we get 0.15. So our mean absolute deviation for this data set is going to be 0.155. Or you can round it to 1.6, whichever one you like. So 0 or 1.55 or 1.6. So again, these questions can be a bit long, but they're all calculator. All you need to do is just calculator all of it, and the important part is that you know what you're doing and you know what you're typing in. Next question, same dot plot, but we want to know what is the range. So to figure out the range of your data set, all you need to do is take your biggest number and subtract it from your smallest number. So 9 is my biggest, 1 is my smallest. 9 minus 1 would give me my range, which is 8. So range for this problem would be 8. Alright, so based on the information in the table, which family had the most variation in their electric bill? Again, asked about most variation, I want the biggest mean absolute deviation. Biggest mean absolute deviation is family D with 25. So family D would have the biggest mean absolute deviation. 11. 11, we want to know based off this table which team has the most variation in height. Again, most variation means I want to know what is the biggest mean absolute deviation, which is team C. So team C would have the most variation because their mean absolute deviation is the highest. Again, mean absolute deviation, variation. Whenever you see the word variation, you're looking at your mean absolute deviation, or your MAD. So variation, MAD. Variation, MAD. And again, we're asking for the most. So most would mean the highest. So 4.3 is the biggest, which is why we chose team C. Alrighty, here we have these two dot plots. This is that Friday, Saturday box plots again. Dot plots, not box plots. We want to examine these visually and which statement best compares these two data. So here we're talking about the range. So remember the range, you take your smallest number and your biggest number and you subtract them. And it looks like this Friday starts at 3 and goes up to 15. Saturday starts at 4 and goes up to 15. So if I were to find the range for Friday, 15 minus 3 would give me 12, and the range for Saturday, 15 minus 4 would give me 11. So it looks like the range of these guests is greater on Friday than 1 by Saturday. So the range of these guests per table is greater on Friday. Remember, Friday was 12, and it was by 1 because it's only 1 bigger than Saturday. Alright, 13. So we have a Sunday, Monday dot plot on 13, and we want to know, based on examining the dot plots visually, which statement best compares the two data sets. So again, we're talking about the range. This on Sunday, it starts at 3 and ends at 15. On Monday, it starts at 3 and ends on 15. So both of them start on 15, both of them start on 3, both of them end on 15. So the range for these two is going to be the same because the starting and ending points on both graphs are the same. So the range is going to be the same. So we have these company A and company B customer service ratings. The mean absolute deviation for company A is 1.55, and the mean absolute deviation for company B is 1.3. Which statement best compares these two companies? Okay, well, company A is a greater mean absolute deviation, right? It's bigger, which means it's going to have more variability in their scores because they have a greater MAD. So company A has more variability simply because 1.55 is bigger than 1.3. Hopefully you guys are starting to see the pattern with variability and MAD. They go hand in hand. So once you kind of see that, these questions get a lot easier when, if you're asked a question which one has the highest or which one has more variability, you should know, oh, variability, I need to look at MAD, and since it's more variability, whichever one has the biggest number for my mean absolute deviation, that one's it. All right, last question here. So team A and team B, based on examining the plots visually, which statement best compares the variability of these two teams? Okay. So variability is the spread of numbers and how far apart your data is from each other. Now, these two graphs, when I look at them, they look almost the same except they're kind of flipped, but the dispersion or how far apart all these dots are doesn't really change. It doesn't necessarily matter what these numbers are on the bottom. When you're talking about variability, you're talking about how far apart and how close numbers are. So since in Team A and in Team B, all of these numbers look like they're almost in the same exact spots, the variability in these two data distributions would be the same. So variability in these two distributions would be the same.